Yay! I have the keys to unlock Pocket Ronnie.
Alright, we're going to be graphing inequalities. Inequality signs look like this, meaning inequality means not equal. So we're not going to have an equal sign in our equation for our lines anymore. We're going to have an inequality. As a reminder, this reads less than if you're reading from left to right. Okay, if I read from left to right, I'll get to the smaller side first, and so that would be less than. This one will be greater than. This one with the dash, the line underneath it, reads less than or equal to, greater than or equal to. We graph inequality lines the same as a regular line, except we have two differences. Whenever it's less than or greater than, you're going to draw a dashed line because we do not want to include the points on that line. When it's less than or equal to or greater than or equal to, it's a solid line. When it has the equal to sign with it, we want a solid line because we're going to include every point on the line. Also, the other difference, so that's one difference. It's either going to be a dashed line or solid line, and then you're going to do some shading. When you have less than, you want to shade below the line. Okay? The way I like to think of it is the line is where a man is standing, and when you are below the line, when you are less than, that's like represents hell, and you're below the line. When you are greater than, and you're standing on the line, greater than represents heaven, so heaven is above, means you shade above the line. Alright, 21b12, we are looking at an inequality because there's not an equal sign. So we have 5y is greater than, you read this from left to right, I came to the bigger opening first, so it's greater than. 5y is greater than 10x plus 20. In order to graph any line, it needs to be in slope-intercept form. This is not in slope-intercept form because we have this 5 here, so we have to get rid of it. So divide this by 5, which means you have to divide everything by 5, which means we have y is greater than 2x plus 4. You graph this the same as a line, except there are two differences. You're either going to have a dashed or a solid line, and then you're going to shade. Because this is greater than, you want a dashed line, which means you're not including the points on the line. So let's just graph this as normal. We have a y-intercept of positive 4. So from our origin, we count up 4. 1, 2, 3, 4. That's my first point. I have a slope of 2. I can make it into a fraction by 2 over 1. So positive 2 over positive 1 means count up 2 over to the right 1. So from my y-intercept, count up 2, 1, 2 over positive 1. So when you draw your line, because this is greater than, then I want a dashed line. Only when it's greater than or equal to. When you have the equal to sign on there, it's a solid line. But when it's greater than or less than, it's a dashed line. So we make this a dashed line. And then we have to shade. I like to think that there is a man standing on the line. The line represents the ground. If I want greater than, I need everything above the line. Greater means above. So you just take this and you just shade everything that's above the line. 21b13, negative 2y is greater than or equal to 8x plus 4. We need to put this in slope-intercept form to graph, which means we have to divide everything by negative 2. Here is the key. When you have an inequality and you are dividing or multiplying by a negative number, you have to flip this inequality sign. Only when you divide or multiply by a negative number do you flip this inequality sign. So since we divided by a negative number, this needs to be flipped. So it's now y, and instead of greater than or equal to, it will now be less than or equal to 8 divided by negative 2, negative 4x minus 2. So this is our new equation to graph. This is less than or equal to, it's got the equal to sign on there, so it will be a solid line. Okay, so we want a solid line, and we are less than, so less than means below, so we will shade below the line. So let's graph this like a normal line. Your y-intercept is negative 2, so from the origin we count down 1, 2, that's one of your points. My slope is -4. We can put it over 1. So remember, this is down 4, over to the right, +1. So +1 means to the right. So from my y-intercept, count down 4. 1, 2, 3, 4. To the right, +1. We said it's going to be a solid line because it's equal to, less than or equal to, which means we include every point on the line. So, and then if my man, how do you determine where's below and above? You always draw your man on top of the line. So it's kind of like he's skiing down the hill. So if you were below the line, because you want to be less than, that would be everything below here. And this is how you would graph this inequality. Okay, 21D, 6 through 8, you have this equation. Y is less than 3x plus 1. So the first thing I recognize is that this is less than, so that means I'm going to have a dashed line. It's not less than or equal to. That would be a solid. Less than means dash. Less than means I'm going to shade below. It's already in slope-intercept form, so I don't need to change anything. So graph it like a normal line. My y-intercept is a +1, so from the origin go up 1. My slope is 3 over 1, so +3 means go up 3. +1 means to the right 1, so from the y-intercept go up 3. 1, 2, 3, over to the right 1. I want a dashed line, and then I said I'm going to shade below. Remember, your man always stands on top of the line. He would be climbing up that hill. So if I want below the line, I need everything here. Okay, now the next thing that it says on number 6, it says plot 2 points, one on each side of the line. Okay, so I need 1 point in the shaded area, and then I need 1 point in the not shaded area. Alright, so I'm just going to come over here and pick this point, -2, 1. Okay, so that's -2, 1. That's in the not shaded area. Okay, then I'm going to come over and pick a point in the shaded area and just say 1, 2, 3, 1. Okay, I'm going to pick this point here that's in the shaded area, 3, 1. So what they're wanting you to do, so the 2 points that I picked, -2, 1, I'm just going to make a note that this was not shaded area. And then I picked the point 3, 1, and that was in the shaded area. Then what they're asking you to do is to test each one of these points. Everything that's in the shaded area, any point that's in the shaded area will make the equation true. Remember, our equation was y is less than 3x plus 1. So I'm going to take my point from the shaded area. Remember, when you have a point, that is an x and a y value. So I can take my x and y value and plug them back into the equation that they give me. My y value is 1, less, oops, no equal sign, just less than. Then I have 3, and then my x value is 3 plus 1. All I did was substitute my x and y value into the equation. So now if I go to do all the calculations, 1 is less than, that would be 3 times 3 is 9, plus 1 is 10. Is 1 less than 10? Yes. So that is a true statement. Any point in the shaded area should be a true statement. Okay? This was a point in the shaded area. Now let's look at your point in the not shaded area, which was -2, 1. Any point that's not in the shaded area will make the equation false. So if I go back into my equation and plug in my x and y value, my y value in my point that's not shaded area is 1. So 1 is less than 3 times my x value, which is -2, because I'm doing the point -2, 1, that's in the not shaded area, plus 1. So 1 is less than 3 times -2 is a -6, and -6 plus 1 is a -5. Is 1 smaller than -5? No. If you look at a number line, there's 0, there's 1, -5 is somewhere over here. 1 is not smaller. Anything smaller than -5 would be to the left. So this is not true. And any number, any point that's in the not shaded area should be not true.